We'll start in about 1 minute. Today during the 8 o'clock session, we're going to review a little bit from section 9.1 and then also review section 9.2 on solving quadratic equations by completing the square. And then in 9.3, we'll learn how to apply the quadratic formula. So first we'll review section 9.1, the square root method. Remember that the standard form of a quadratic equation in the variable x looks like ax squared plus bx plus c equals 0. So the 0 was not put in, but and this is where a, b, and c are constants. And the one restriction is that a, which is the coefficient of x squared, it can't be 0. Okay, so we'll review the square root property. If we have x squared equals 49, we can apply the square root property without any preliminary work, and we write x equals positive and negative square root of 49. But the square root of 49 can be simplified, so we write x equals positive and negative 7. If you want to list the solution separately, x equals 7 and x equals negative 7 are the solutions. If we have y squared equals 11, apply the square root property. Y equals positive and negative square root of 11. The square root of 11 cannot be simplified any further, so this is an okay way to write the two solutions. In the next one, we have a binomial x minus 3 squared equals 19. This is all prepared to apply the square root method. And so we get x minus 3 equals positive and negative square root of 19. The square root of 19 can't be simplified further, so we can write the two solutions as x equals 3 plus and minus the square root of 19. And then one more example involving the square root property. If y plus 2 squared is 9, then we can write y plus 2 equals positive and negative square root of 9. The square root of 9 simplifies to 3, so in the next step, I'll write y equals negative 2 plus and minus 3. We can simplify further, so we have to write the solutions separately. One solution is negative 2 minus 3, or negative 5, and the other solution is negative 2 plus 3, or positive 1. Okay, now we'll review what we talked about from section 9.2, which is solving quadratic equations by completing the square. So this one, this first one, x squared plus 10x minus 7 equals 0. So the first thing we do is add 7 to both sides. When using this method, we want the x squared term and the x term on one side of the equation, and then the constant moved to the other side. Then we check to see what the coefficient of the squared term is. The coefficient of x squared here is 1. And so dividing every term by 1 doesn't change anything. So we now add a number to both sides so that the left-hand side is a perfect square trinomial. Okay, so when the coefficient of x squared is 1, the number that we need to add to both sides is determined by first taking 1/2 of the coefficient of x. So 1/2 times 10 is 5. And then we square that number. 5 squared is 25. So if we add 25 to both sides of this equation, the left-hand side will be a perfect square trinomial. So we add 25 to both sides. And the left-hand side is now a perfect square trinomial. And when we write it in factored form, we write it as x plus 5 squared equals 32. And then to solve for x, now we apply the square root property that we just reviewed. So here we write x plus 5 equals positive and negative square root of 32. The square root of 32 can be simplified, and you're experienced enough to know how to simplify the square root of 32. So in the next step, I'll do two things at once. I'll subtract 5 from both sides. So x equals negative 5 plus and minus. And then when we simplify the square root of 32, that's the square root of 16 times the square root of 2. But the square root of 16 is 4. So we write the solutions as negative 5 plus and minus 4 times the square root of 2. Okay, let's do a few more of these. Solve this by completing the square. Y squared minus 12y minus 24 equals 0. Step 1, we write y squared minus 12y. Leave some space. We're adding 24 to both sides, so y squared minus 12y equals 24. The coefficient of the y squared term is already 1. So dividing every term by 1 doesn't change anything. Now we want to add a number to both sides of the equation so that the left-hand side becomes a perfect square trinomial. Okay, so the coefficient of y is negative 12. We want first to find 1/2 of that number. 1/2 times negative 12 is negative 6. And then we square that number. Square the number negative 6, which is positive 36. So we're going to add 36 to both sides, and we get y to the second minus 12y plus 36 equals 24 plus 36. The left-hand side is now a perfect square trinomial, so we're going to write it as a binomial squared. And the right-hand side is 60. Okay, then we'll just review how we know what binomial to square to get the perfect square trinomial. Well, you can always use the AC method to factor it, but we can do it much more quickly. Since the trinomial has y squared, we know the binomial has to have y in it. And since the perfect square trinomial has minus plus, we know that we have to have a minus sign in the binomial. Or you can just remember when we took 1/2 of the coefficient of y, 1/2 of negative 12 is negative 6. We just write y minus 6. So y minus 6 quantity squared equals 60. And now we apply the square root method. When applying the square root method here, we get y minus 6 equals positive and negative square root of 60. The square root of 60 can be simplified. The largest factor of 60 that's a perfect square is 4. 4 times 15 is 60. So in the next step, I'll add 6 to both sides and also write the square root of 60 in simplified form. So our two solutions are y equals 6 plus and minus 2 times the square root of 15. Okay, the next example, a little bit more work to do on this one, only slightly more. We already have the x squared term and the x term on one side of the equation, and the constant is on the other side. But this time the coefficient of x squared is not 1. So we're going to start by dividing every term on both sides by -2. Because before we complete the square, we want the coefficient of x squared to be +1. So we'll divide every term on both sides by -2, and we get x squared minus 14x. I'm going to leave space, and then we get equals -10. Okay, now we add a number to both sides so that the left-hand side is a perfect square trinomial. So since the coefficient of x squared here is 1, we take 1/2 of -14, which is -7. And then we're going to square the number -7, which is +49. Okay, so we'll add 49 to both sides, and we get x squared minus 14x plus 49 equals -10 plus 49. And now the left-hand side is a perfect square trinomial. The binomial is x, and then half of -14 is -7, so x minus 7 squared equals 39. And now we apply the square root method. So our two solutions are first we write x minus 7 equals positive and negative square root of 39. The square root of 39 cannot be simplified any further, so there's just one step left. Add 7 to both sides, and we get x equals 7 plus and minus the square root of 39. Those are the two solutions. Okay, another example. I'm doing more examples than is probably necessary for the reason that every quadratic equation can be solved by completing the square. So the more you know about that, the better off you'll be. Okay, on this one, y squared minus 5y minus 2 equals 0. First add 2 to both sides, so we get y squared minus 5y equals 2. The coefficient of y squared is 1, so dividing every term by 1 doesn't change anything. And now we find the number that we add to both sides, so that the left-hand side is a perfect square trinomial. The coefficient of y is -5, so we find 1/2 of -5. 1/2 of -5 is just -5 halves. And then we square that number. The number -5 halves squared. That just means -5 halves times -5 halves, so it's positive 25/4. And then we add 25/4 to both sides of this equation, and we get y squared minus 5y plus 25/4 equals 2 plus 25/4. The left-hand side is now a perfect square trinomial. So we write y, let's see, since the coefficient of y squared is 1, 1/2 of -5 is -5/2. So in the binomial, we write -5/2. So the binomial y minus 5/2 squared equals 2 plus 25/4. Before we can add these, we have to have a common denominator. So 2 is equivalent to 2 over 1. And with a common denominator of 4, we replace 2 with 8 over 4. And 8 over 4 plus 25 over 4 is 33 over 4. And now we apply the square root method. And so the left-hand side, y minus 5/2 equals positive and negative square root of the entire fraction, the square root of 33/4. But notice the square root of 33/4 is the same as the square root of 33 over the square root of 4. And in the denominator, the square root of 4 is simplified to 2. So we'll write this as y minus 5/2 equals positive and negative square root of 33 in the numerator divided by 2. And then one last step, just add 5/2 to both sides. So we get y equals 5/2 plus and minus the square root of 33 over 2. Okay, now we'll move on to section 9.3. Section 9.3 is about the quadratic formula, solving quadratic equations by the quadratic formula. Okay, as I already mentioned in this top line, any quadratic equation can be solved by completing the square. So consequently, a formula can be derived by completing the square to solve any quadratic equation. And we're going to derive that formula called the quadratic formula. So we begin with a quadratic equation in standard form. And this represents every quadratic equation that can possibly exist, because A, B, and C just represent real numbers, and the only restriction is that A can't be 0. Okay, so we'll just go through the same process that we did in the previous examples to solve this equation for x by completing the square. Okay, step 1, we want to subtract c from both sides because we want the x squared term and the x term on one side of the equation and the constant moved to the other side. So that's why we subtracted c from both sides. We want the coefficient of x squared to be equal to 1. So that means we need to divide every term on both sides by a. So when we divide every term on both sides by ax squared divided by a is just x squared. And then b times x divided by a, we'll write that as b over a times x. And then on the right-hand side, divide negative c by a, we get, I'll write it as negative c over a. Okay, then we're going to add a number to both sides of the equation so that the left-hand side is a perfect square trinomial. The process is exactly the same as we saw in the previous examples. The coefficient of x is b over a. But first, note that the coefficient of x squared is 1. So that means we want to take 1/2 of the coefficient of x. So that means 1/2 of b over a. And 1/2 times b over a is just b over 2a. And then we're going to square this number. When we square the number b over 2a, that just means b over 2a times b over 2a. So in the numerator, b times b is b to the second. And in the denominator, 2a times 2a is 4a to the second. Okay, so this is the number that we add to both sides of this equation. On the left-hand side, we get x squared plus b over ax plus b squared over 4a squared. And we add that same number to the right-hand side, negative c over a plus b squared over 4a squared. Okay, so the left-hand side is now a perfect square trinomial, so we'll write it as a binomial squared. And then the right-hand side, we want to write the right-hand side as a single fraction with a common denominator. So the denominator of negative c over a is a, and the denominator of this b squared over 4a squared is 4a squared. So the least common denominator is 4a squared. So that means for this fraction, negative c over a, we're going to multiply the numerator by 4a and multiply the denominator a by 4a so that it becomes 4a to the second. Okay, so we'll do those things in the next step. This is now a binomial equal to a binomial squared because it's a perfect square trinomial. So what binomial is it? Well, since the trinomial has 1x squared, the binomial has to have x in it. And then how do I know what follows? Well, it's just 1/2 of b over a, or b over 2a, because 1/2 times b over a is b over 2a, so plus b over 2a. So this is no different than in the numerical examples when solving by completing the square. This plus b over 2a is the same number we got over here when we took 1/2 of the coefficient of x, b over 2a. Okay, then the right-hand side, we want a common denominator. So I'm going to rearrange the terms. Instead of minus c over a plus b squared over 4a squared, I'm going to put the positive b squared over 4a squared to the left, and then we're subtracting c over a times 1 in the form 4a over 4a. I'm just multiplying by 1, so I'm not changing the value, but the form that 1 takes allows us to have a common denominator. So the right-hand side, I can just simplify it all at once now. The denominator is a common denominator, 4a to the second. And in the numerator, we have b to the second minus c times 4a, but we'll write it as b to the second minus 4ac. And you can verify that this is correct when you apply the operator to the numerators. Okay, just to make it look a little more compact, I'll write this left-hand side, x plus b over 2a squared, and then the right-hand side, b squared minus 4ac over 4a to the second. Okay, we're now ready to apply the square root property. So when we apply the square root property, the left-hand side becomes x plus b over 2a And the right-hand side becomes positive and negative square root of the right-hand side, square root of b squared minus 4ac in the numerator and 4a to the second in the denominator. Okay, on the right-hand side, notice the square root of that entire fraction, b squared minus 4ac over 4a squared. We have a perfect square in the denominator, so we can simplify the square root of b squared minus 4ac over 4a squared. I'll do that in the next step, so that I'll just leave the left-hand side the way it is for now. X plus b over 2a equals positive and negative. In the numerator, the square root of b squared minus 4ac. And in the denominator, the square root of 4a squared is just 2a. Okay, now we're just one step away from solving for x. If we just subtract b over 2a from both sides, we'll have the two solutions. So I'll do that. I'm going to write it with a single denominator, all over 2a, because the denominators are already common. And in the numerator, well, we're subtracting b over 2a. So in the numerator, I have negative b, and then plus and minus the square root of b squared minus 4ac. Okay, so this is called the quadratic formula that can be used to solve any quadratic equation. But since it's derived by completing the square, the implication is if you don't want to memorize the quadratic formula, you don't really have to if you know how to solve a quadratic equation by completing the square. But it's probably a good idea to know what the quadratic formula is. There will be some questions on Newton and possibly on a future quiz and test where you'll have to be able to produce certain things about the quadratic formula. Okay, so now something that you need to know. The number b to the second minus 4ac, that's the number that's inside the square root in the quadratic formula. This number, b to the second minus 4ac, is called the discriminant. So the discriminant tells you how to classify the solutions, because we know pretty much all we need to know about square roots of real numbers. Okay, so the discriminant indicates how to classify the solutions to ax squared plus bx plus c equals 0. If the discriminant is positive, that is, if b to the second minus 4ac is greater than 0, we know that the square root of a positive real number is a positive real number. So that means the equation ax squared plus bx plus c equals 0 has two distinct real valued solutions, or two different real numbers that are solutions. On the other hand, well, in a second case, if b to the second minus 4ac is negative, or if b to the second minus 4ac is less than 0, then the equation ax squared plus bx plus c equals 0 has two distinct non-real solutions. We already know that because we know that the square root of a negative number is not a real number. So that means the solutions to the quadratic equation are two different non-real solutions if the discriminant is negative. And then the third case is if the discriminant is exactly 0. Well, you know that the square root of 0 is 0, so there's no problem with taking the square root of 0. But if the discriminant is 0, it means that the quadratic equation has one repeated real solution. It's just one solution, but we call it repeated because it's represented by a particular binomial squared. So this third case right here, if the discriminant is 0 when using the quadratic formula, it means that the quadratic expression is either a perfect square trinomial or a multiple of a perfect square trinomial. Okay, we'll look at some examples where we solve equations using the quadratic formula. So at the top, I have a reminder of what the quadratic formula is. The solutions to ax squared plus bx plus c equals 0 are x equals, in the numerator, negative b plus and minus the square root of b squared minus 4ac, and it's all divided by 2a. So remember that you divide everything in that numerator by 2a. Okay, in this particular example of a quadratic equation, the value of a is 1 because it's 1x squared. B is the coefficient of x, so in this case b is negative 7. And c is negative 2. Since we have minus 2, subtracting 2 is equivalent to adding negative 2, so the value of c is negative 2. Okay, then we just write down the solutions using the quadratic formula. Well, the first thing we write in the numerator on the left is the negative of b. Well, b is negative 7, so we compute the negative of negative 7. And then plus and minus. And then inside the square root is the discriminant, b to the second minus 4ac. So we're going to square the number negative 7. If you want to write it correctly, you have to put the number negative 7 in parentheses and then square that quantity. And then minus 4 times 1, a is 1, and then times negative 2. Okay, that is all in the numerator. And then we divide it all by 2 times a. In this case, divide by 2 times 1. Okay, then we'll just apply rules of arithmetic and simplify a little bit. So in the numerator, the negative of negative 7 is positive 7, and then plus and minus the square root of some number, and then in the denominator, 2 times 1 is 2. Okay, so we'll do a little bit more detail in the arithmetic inside the square root. The number negative 7 squared is positive 49. And we're subtracting 4 times 1 times negative 2. So as usual, you have to be careful with subtracting and negatives. So if we subtract 4 times 1 times negative 2, that means we're subtracting negative 8. So we're a couple of steps away from the simplified result. So inside the square root, 49 minus negative 8, that's 49 plus 8. This is a little more detail than is necessary, but if you have a habit of dropping negatives or miscomputing subtracting of negatives, then more detail is probably helpful. Okay, so this last step, the solutions are 7 plus and minus the square root of 57, all divided by 2. The square root of 57 cannot be simplified further, so these are the two solutions. One of the solutions is 7 plus the square root of 57 over 2. The other solution is 7 minus the square root of 57 over 2. So you should be able to write the solutions separately if necessary. Okay, in the next example, solve 3x squared minus 5x plus 1 equals 0. Well, to solve this by completing the square method, it can be done, but there's a fair amount of fraction arithmetic that would arise. So maybe just using the quadratic formula would be a better choice. So in this quadratic equation, first make sure that it's in standard form. That means one side is 0. And then the value of a is the coefficient of the x squared term. So in this example, a is 3. B is -5, the coefficient of x. And c is +1. Okay, so we put those numbers into the quadratic formula. X equals the negative of b. So in this case, it's the negative of -5 plus and minus the square root. Inside the square root, we have the number -5 squared minus 4 times 3 times 1. And this is all divided by 2 times 3. So I'll get the quadratic formula in view. So the negative of -5, that's the negative b. And then inside the square root, b squared, that's the number -5 squared. And then minus 4 times a times c is minus 4 times 3 times 1. And the denominator is 2 times a, in this case, 2 times 3. So you'll want to make sure that you have all of the numbers written down appropriately. It only takes one mistake to throw everything off. Okay, so we'll do the arithmetic. The negative of -5 is 5. And then positive, or plus and minus the square root of some number. The denominator, 2 times 3 is 6. Okay, so when you square the number -5, you get 25. And we're subtracting 4 times 3 times 1, we're subtracting 12. And we're just one step away from the two solutions. X equals 5 plus and minus the square root of 13, all divided by 6. The square root of 13 cannot be simplified further, so these are the two solutions. Okay, the next example, this quadratic equation is in standard form. It always has to be in standard form so that you correctly identify the values of a, b, and c. So in this one, a is -2, b is +1, and c is +4. Okay, so x equals negative b. B is 1, so -1 is negative b, plus and minus the square root of b squared, which is 1 squared, and then minus 4 times a times c. all divided by 2 times a. Okay, then we do the arithmetic. We have x equals, in the numerator, -1 plus and minus the square root of some number. In the denominator, we have -4. And inside the square root, 1 squared is 1, and we're subtracting 4 times -2 times 4. So we're subtracting -32. So 1 minus -32. Okay, then we write -1 plus and minus the square root of 1 minus -32 is 1 plus 32. And then all divided by -4. So we write -1 plus and minus the square root of 33, all divided by -4. Well, if you're just writing the solutions on paper, this is an okay way to write the solutions. If you're typing solutions in the Newton homework, the software requires that the denominator be positive instead of negative. So we can fix that. If you multiply by 1 in the form -1 over -1, then we can get everything the way that we want. So just think of what would happen if you multiply the numerator, all of the terms in the numerator by -1, and then multiply the denominator by -1. Okay, so -1 times -1 is 1, so we have 1. And then plus and minus the square root of 33 multiplied by -1. That just becomes minus plus the square root of 33. And so minus plus the square root of 33 is no different than plus minus the square root of 3. So I can just write plus minus the square root of 33. And then when we multiply the denominator by -1, -1 times -4 is 4. So these are the solutions with a positive number in the denominator. Okay, you can avoid all of that right from the start if you want to. And this sort of thing was mentioned before a few days ago, before we took the test last Friday. We're starting out with a quadratic equation in standard form, and the leading coefficient is negative. Well, we can get rid of that in an equation if right from the start we multiply every term on both sides of this equation by -1. We'll get a quadratic equation whose solutions are the same as the solutions of this one, but whose leading coefficient is positive. Okay, so if we multiply every term on both sides of this equation by -1, we get the equation 2x to the second minus 1x, or just minus x, minus 4 equals 0. Then if you use the quadratic formula with a equals 2, b equals -1, and c equals -4, then you'll get the same solutions, but the denominator will already be positive because the value of a is now positive. So I recommend that before applying the quadratic formula, make sure that the coefficient of x squared is positive. You don't have to do that, but I just recommend it. Okay, we'll look at a couple more examples. In these examples, we're first going to find the discriminant, b to the second minus 4ac, and then classify the solutions. Remember, the discriminant is the number that's inside the square root. So if the discriminant is positive, it means the quadratic equation has two different real valued solutions. If the discriminant is negative, it means the quadratic equation has two different non-real solutions. And if the discriminant is 0, the quadratic equation has one repeated real valued solution. Okay, so in this one, A is 6, B is negative 7, and C is positive 9. And so the discriminant, b to the second minus 4ac, well, we square the number negative 7, and then we subtract 4 times 6 times 9. So when we square the number negative 7, we get 49. And then we're subtracting 4 times 6 times 9. So let's see, that's minus 216. Well, 49 minus 216 is clearly negative. So let's do a little bit more arithmetic. So that's negative 167. Yeah, negative 167. Okay, so that means the two solutions are non-real, two different non-real solutions. So I'll write that, two different non-real solutions. Okay, so let's put those numbers in the quadratic formula. We're solving for y this time. So y equals the negative of negative 7, which is, I'll write it out, the negative of negative 7, plus and minus. We already found the discriminant. It's negative 167. And then all divided by 2 times a, or 2 times 6. And then a little bit more arithmetic. The negative of negative 7 is 7, plus and minus. And we know how to simplify the square root of a negative. So think of this as the square root of negative 1 times the square root of 167. And so I'll write plus and minus the square root of 167 times I on the outside of the square root, and then divided by 12. Okay, we have a couple of minutes left. Let's do the same thing on this next one. N squared minus 8n plus 5. So on this one, A is 1, B is negative 8, and C is 5. So we'll compute the discriminant, b to the second minus 4ac. So this one is negative 8 squared minus 4 times 1 times 5 The number negative 8 squared is 64, and we're subtracting 20. And so the discriminant is positive 44. Okay, so that means two different real solutions if the discriminant is positive. And this will be the last problem. N is equal to the negative of negative 8 plus and minus the square root of the discriminant, 44, divided by 2 times a, 2 times 1. So the negative of negative 8 is 8. We can simplify the square root of 44. The largest factor of 44 that's a perfect square is 4. The square root of 4 is 2. And so 8 plus and minus 2 times the square root of 11, all divided by 2. And one common factor of 2 cancels from every term in the numerator with the denominator. So we can write the solutions as 4 plus and minus the square root of 11. Okay, it's 10 till, so it's time to quit for today. Tomorrow we'll review the quadratic formula and then do what's next after that. We'll start in about half a minute. During the 9 o'clock session, we will cover section 9.2 on how to solve quadratic equations by completing the square. But first, we'll review what we talked about from section 9.1. Okay, from section 9.1, that's where we solved equations by the square root method, or the square root property. And the standard form of a quadratic equation in the variable x is ax squared plus bx plus c equals 0. That's supposed to be a 0, where a, b, and c are constants. And the only restriction is that the number a cannot be 0. Okay, we'll look at these examples. We saw examples like these before test 3. Solve each equation using the square root property. If x squared equals 49, then applying the square root property, we get x equals positive and negative square root of 49. And we always simplify square roots when we can. Since the square root of 49 is 7, the two solutions are positive and negative 7. If you write the solution separately, it's x equals 7 and x equals negative 7. Okay, in the next example, y squared equals 11. Apply the square root property. We get y equals positive and negative square root of 11. And the square root of 11 cannot be simplified further, so these are the two solutions. The next one is a little bit more involved. The binomial x minus 3 squared equals 19. This is all prepared to apply the square root property, and we get x minus 3 equals positive and negative square root of 19. The square root of 19 cannot be simplified further, so we can just write the two solutions as x equals 3 plus and minus the square root of 19. So make sure that you know how to write the solutions separately if necessary. So I'll go ahead and do that. One of the solutions is x equals 3 minus the square root of 19. And the other one is x equals 3 plus the square root of 19. Okay, the final example in this review, the binomial y plus 2 squared equals 9. So it's all prepared to apply the square root property. So we write y plus 2 equals positive and negative square root of 9. The square root of 9 simplifies to 3. So in the next step, I'll write y equals negative 2 plus and minus 3. Since we can simplify further, we have to do that. In this case, one of the solutions is y equals negative 2 minus 3, which is negative 5. And the other solution is y equals negative 2 plus 3, which is 1. In the next section, 9.2, we're going to learn how to solve quadratic equations by completing the square. Okay, we'll read some information about this method. In the first sentence, solving a quadratic equation by completing the square involves some preliminary work. But once that work is complete, the equation can be solved by using the square root property. The expression completing the square in this context simply means to create a perfect square trinomial. So recall that a perfect square trinomial is the result of squaring a binomial. Here are a couple of examples of how to create a perfect square trinomial. This first one, if we square the binomial x minus 3, that just means to multiply x minus 3 times x minus 3. And when you multiply those, you get x to the second minus 3x plus 9. Combine the like terms, we get x squared minus 6x plus 9. So x squared minus 6x plus 9 is a perfect square trinomial. The next example, if you square the binomial 4y plus 5, that just means 4y plus 5 times 4y plus 5. And we know how to multiply two binomials. We get 16y to the second plus 20y plus 20y plus 25. And then combine the like terms, we get 16y to the second plus 40y plus 25. This is a perfect square trinomial. Okay, we're going to use what we know about perfect square trinomials. Let's read this next sentence. Since a perfect square trinomial has characteristics that are known under appropriate conditions, a perfect square trinomial can be constructed. The following example illustrates what to do when completing the square. We're going to begin with x squared plus 6x. When we solve quadratic equations by this method called completing the square, we always want the coefficient of the squared term to be 1. So observe that the coefficient of x squared is 1. Then we're going to compute 1/2 of the coefficient of x. So in this example, the coefficient of x is 6, and so we compute 1/2 of 6, and that's just 1/2 times 6, which is 3. In the next step, we square the number found in step 2. The number we found in step 2 is 3, so when we square 3, 3 squared equals 9. Then in the fourth step of this procedure, we add the number that we found in step 3 to x squared plus 6x. The number we found in step 3 is 9, so we add 9 to x squared plus 6x to get x squared plus 6x plus 9. And then finally, the trinomial created in step 4 is a perfect square trinomial because x squared plus 6x plus 9 is equal to the binomial x plus 3 squared. That's an application of the definition of a perfect square trinomial. Okay, we'll do a number of examples where we create perfect square trinomials. So this will give us a bunch of practice. So create perfect square trinomials below by completing the square. Okay, first note, the coefficient of x squared is 1. the coefficient of x is 2. So the number that we're going to add to x squared plus 2x in order to create a perfect square trinomial depends upon what the coefficient of x is. So the coefficient of x is 2. We take 1/2 of 2, which is just 1/2 times 2, which is 1. And then we square that number. 1 squared is 1. So if we add 1 to x squared plus 2x, we have a perfect square trinomial. So I'll just make a note. We add this to x squared plus 2x. And when we add that to x squared plus 2x, we now have a perfect square trinomial. That means that it's equal to some binomial squared. This one is simple enough that you can tell pretty much by looking what the binomial is that you square to get the perfect square trinomial, x squared plus 2x plus 1. But I'll explain what we can know in general that will help when it's not obvious what the binomial is. So since the perfect square trinomial has x squared in it, the binomial that we're squaring has to have x in it, because x times x is x squared. And then how do we know what follows? Well, what follows the x inside the parentheses is the same number we got when we took 1/2 of the coefficient of x. The coefficient of x is 2. 1/2 of 2 is 1, positive 1, so we write x plus 1 squared, quantity squared. And you can verify by squaring the binomial that you have factored it correctly. Okay, in the next example, this one is about as simple as the one we just did. First, note the coefficient of x squared is 1, and the coefficient of x is -2. So we want to add a number to x squared minus 2x to create a perfect square trinomial. So this time we take 1/2 of -2, which is -1, and then we square that number. -1 squared is positive 1. So we're going to add this to x squared minus 2x, and we now have a perfect square trinomial. This one is pretty much easy to do, but we'll go through the steps that will help you when it's not as obvious what the binomial is that you're going to square. So the binomial has to have an x in it because the trinomial has x squared. And then how do we know what follows x in the binomial? It's the same number that we get when we take 1/2 of -2. So 1/2 of -2 is -1, so that means we write -1. And so x minus 1 quantity squared is equal to x squared minus 2x plus 1. The next example will be a little stickier, but it won't be too bad if you took note of what I was pointing out in the previous examples. First, note that the coefficient of x squared is 1. Now we want to add a number to x squared plus 7x to create a perfect square trinomial. So the coefficient of x is 7, so we take 1/2 of 7. 1/2 of 7 is 7/2. Then we square that number. We're going to square 7/2, and that just means 7/2 times 7/2, which is 49/4. Okay, so this is the number that we add to x squared plus 7x to create a perfect square trinomial. So I'll just note, add this to x squared plus 7x. Okay, we add that to x squared plus 7x. we now have a perfect square trinomial. And so the binomial that we square to get x squared plus 7x plus 49/4 can be found using the same method that I explained in the previous examples. The binomial has to have an x because the perfect square trinomial has x squared. X times x is x squared. Then how do we know what follows x inside the parentheses? Well, what follows is the same number we got when we took 1/2 of 7. 1/2 of 7 is positive 7/2. So on the inside, we write x plus 7/2. So in other words, the binomial x plus 7/2 squared equals this perfect square trinomial, x squared plus 7x plus 49/4. Okay, so if you cut those explanations, then you'll be able to create a perfect square trinomial anytime that you have to. So we'll do a few more examples just to get practice. We want to add a number to x squared minus 13x to create a perfect square trinomial. The coefficient of x squared is 1. That's what we want. Then we take 1/2 of the coefficient of x. So 1/2 of negative 13 is negative 13/2. Then we square that number. We square negative 13/2. And so negative 13/2 is positive 169/4. Okay, so this is the number that we're going to add to x squared minus 13x to create a perfect square trinomial. So we write x squared minus 13x plus 169/4. This is a perfect square trinomial. It has to be equal to some binomial squared. Okay, so we're going to apply the same process that you've seen happen 3 times before. In the binomial, we have to have x, since the perfect square trinomial has 1x squared in it. And then to determine what follows x inside the parentheses, well, what follows is the same number we got when we took 1/2 of negative 13. 1/2 of negative 13 is negative 13/2. So that means we're going to write minus x minus 13/2. If you're ever in doubt about what you write for the binomial, you can always test it by squaring that binomial. And if it equals the trinomial, then you know that you've done it correctly. Okay, the next couple will seem simple by comparison. X squared plus 10x. The coefficient of x squared is 1. So that means we want to take 1/2 of the coefficient of x. 1/2 of 10 is 5. Then square that number. 5 squared is 25. So we're going to add 25 to x squared plus 10x. This is now a perfect square trinomial. So it's equal to some binomial squared. The binomial has to have x, and what follows x, the number that follows x is what we get when we take 1/2 of 10. 1/2 of positive 10 is positive 5. So the binomial is x plus 5, and then quantity squared. Okay, one more. X squared minus 24x. The coefficient of x squared is 1, so that means we want to take 1/2 of negative 24, which is negative 12. And then we square negative 12. When we square negative 12, we get positive 144. Okay, so we're going to add positive 124 to x squared minus 24x. This is now a perfect square trinomial, which means that it can be written as a binomial squared. The binomial has to have x in it because the perfect square trinomial has 1x squared. And then the rest of the binomial is what we get when we take 1/2 of negative 24. 1/2 of negative 24 is negative 12, so that means we write x minus 12. Okay, this is what's behind solving quadratic equations by completing the square. So now we'll solve a few quadratic equations by this method. Okay, so here's the procedure. We want to solve each of these equations by completing the square. Okay, so this first one, x squared plus 10x minus 9 equals 0. Step 1, add 9 to both sides. We want the x squared and the x term on one side of the equation by itself. So I'm going to add 9 to both sides. And notice that I'm leaving some space to suggest that I'm going to fill that in. But when working out problems on quizzes and tests, make sure that you show several steps rather than doing all of the work in a single step, because I will want to know if you understand the process. So you'll have to demonstrate that by 2 or 3 or 4 steps, whatever is necessary. So this is the first step, x squared plus 10x equals 9. The coefficient of x squared is 1. If the coefficient of x squared is not 1, the next step would be to divide every term on both sides by the coefficient of x squared. So if you divide every term by 1, nothing changes. So for this one, we are all ready to create a perfect square trinomial by adding a number to both sides. So we have x squared plus 10x equals 9. And in this step, we'll add a number to both sides so that the left-hand side is a perfect square trinomial. Well, since the coefficient of x squared is 1, we take 1/2 of 10, which is 5. 5 squared is 25, so we're going to add 25 to both sides. And the left-hand side is now a perfect square trinomial, so we write it as the binomial x plus 5 squared, and the right-hand side is 34. So this equation is now prepared to apply the square root property. The goal is to find the solutions to that equation. So now we can apply the square root property, which we reviewed earlier. So if x plus 5 quantity squared equals 34, applying the square root property, we get x plus 5 equals positive and negative square root of 34. And the square root of 34 cannot be simplified any further, so we can get both of the solutions by writing x equals negative 5 plus and minus the square root of 34. Okay, in the next example, we have y squared minus 8y minus 22 equals 0. Okay, so first add 22 to both sides because we want the y squared term and the y term by itself. So I'm leaving space to suggest that I'm going to fill that in. Okay, the coefficient of y squared is 1. If you divide every term on both sides by 1, nothing changes. But just get into the habit of thinking about dividing every term on both sides by the coefficient of the squared term. Okay, then we want to add a number to both sides so that the left-hand side becomes a perfect square trinomial. I didn't do this in the previous example, but to determine what number, well, we did it, I just didn't write it down, but to determine what number to add to both sides, we take one half of the coefficient of y. So 1/2 of -8 is -4. And then when we square the number -4, we get positive 16. Okay, so we add 16 to both sides of that equation, and we get y squared minus 8y plus 16 equals 22 plus 16. The left-hand side is now a perfect square trinomial, so it's equal to some binomial squared. The binomial is y minus 4 because -4 is 1/2 of -8. And then the right-hand side is 38. And this is all prepared now to apply the square root property. So when we apply the square root property, we get y minus 4 equals positive and negative square root of 38. The square root of 38 cannot be simplified any further. So that means we can write both of the solutions. Y equals 4 plus and minus the square root of 38. I'll write the solution separately just to remind you that sometimes you'll have to be able to write the solution separately. One solution is y equals 4 minus the square root of 38. And the other solution is y equals 4 plus the square root of 38. Okay, in the next example, this is something we haven't seen yet, at least not when solving equations by completing the square. We already have the x squared term and the x term on one side of the equation, but this time the coefficient of x squared is not 1. Well, before solving by completing the square, we want the coefficient of x squared to be 1. So the first step here is to divide every term on both sides by -3. Okay, when you divide -3x squared by -3, you get positive 1x squared. And then subtract 36x by -3, you get minus 12x. Okay, I'm going to leave a little bit of space. And then on the right-hand side, 33 divided by -3 is -11. Now that the coefficient of x squared is 1, we can find the number that we need to add to both sides so that the left-hand side is a perfect square trinomial. Okay, so we take 1/2 of the coefficient of x, 1/2 of -12, which is -6. Then we square the number -6, which is positive 36. And then we add 36 to both sides of that equation. And we get x squared minus 12x plus 36 equals -11 plus 36. The left-hand side is now a perfect square trinomial. So it's equal to some binomial squared. And the right-hand side, -11 plus 36 is 25. Hey, no doubt you see what binomial is needed. The binomial has to have x in it because the coefficient of x squared is 1. And then the number that follows the x is the same number we got when we took 1/2 of negative 12. 1/2 of negative 12 is negative 6, so that means we write x minus 6 quantity squared equals 25. Now we can apply the square root property. We get x minus 6 equals positive and negative square root of 25. The square root of 25 simplifies to 5. So we'll write in the next step x equals positive 6 plus and minus 5. In this case, we can't leave it in this form because we can simplify further. So this time we do have to write the solution separately. One is x equals 6 minus 5, or x equals 1. And the other solution is x equals 6 plus 5, or x equals 11. Okay, one more example. This one will involve fractions. So first, if we're going to solve by completing the square, we want the y squared term and the y term on one side of the equation and the constant on the opposite side. In this case, the first thing we do is add 3 to both sides. So we get y squared minus 5y. Leaves a little bit of space and then equals 3. The coefficient of y squared is 1, so dividing every term on both sides by 1 doesn't change anything. So now we can add a number to both sides so that the left-hand side is a perfect square trinomial. So once again, we just take 1/2 of the coefficient of the y term, in this case, 1/2 of negative 5 is negative 5/2. And then we square the number negative 5/2. And that just means negative 5/2 times negative 5/2, which is 25/4. Okay, so we'll add 25/4 to both sides of this equation, and we get y squared minus 5y plus 25/4 on the left-hand side, and on the right-hand side, 3 plus 25/4. Okay, so on the right-hand side, we have to do the fraction arithmetic, adding 3 to 25/4. And the left-hand side is now a perfect square trinomial. So it's equal to some binomial squared. Since the coefficient of y squared is 1, the binomial has to have y. And then what follows y? What follows y in the binomial is the same number we got when we took 1/2 of negative 5. 1/2 of negative 5 is negative 5/2. So on the inside of the parentheses, we write y minus 5/2. And then the least common denominator is 4. Think of 3 over 1 as 12 over 4. So we add 12 over 4 to 25 over 4, and we get 37 over 4. Okay, finally, we have this in a position that we can apply the square root property. So upon applying the square root property, y minus 5/2 equals positive and negative square root of the entire fraction, 37/4. But we're experienced enough to know how to simplify the square root of 37/4. In the denominator, the square root of 4 will simplify to 2. So in the next step, I'll add 5/2 to both sides. So we get y equals 5/2. And then plus and minus the square root of 37 in the numerator. In the denominator, the square root of 4 simplifies to 2. Okay, so those are the two solutions. One option, you can write the difference the sum and the difference using two different fraction bars, but another way to write it is in the numerator, 5 plus and minus the square root of 37, all divided by 2. For written quizzes and tests, either form is acceptable. And then if you're working in Newton, you'll just have to read the directions carefully and then do whatever the directions say to do. Okay, we'll do more examples. The next few will be slightly more involved. Okay, solve the equations by completing the square. So this first one, 5x to the second plus 15x minus 50 equals 0. Step 1, add 50 to both sides. We'll get 5x to the second plus 15x. Leave a little bit of space, and then that's equal to 50. Well, the coefficient of x squared isn't 1, so we want, in the next step, to divide every term on both sides by 5. When we divide every term on both sides by 5, we get x squared plus 3x equals 10. Now that the coefficient of x squared is 1, we'll find the number that we need to add to both sides so that the left-hand side is a perfect square trinomial. The coefficient of x is 3, so we find 1/2 of 3, which is 3/2. And then we square that number. 3/2 squared is 9/4. Okay, so we're going to add 9/4 to both sides of this equation. And we'll get, on the left-hand side, x squared plus 3x plus 9/4 equals 10 plus 9/4. The left-hand side is now a perfect square trinomial. And on the right-hand side, we'll have to find a common denominator to add 10 to the fraction 9/4. Okay, so the left-hand side is equal to some binomial squared. And the right-hand side, think of 10 as 40 over 4. And 40 over 4 plus 9 over 4 is 49/4. And then the binomial that we square, the binomial has to have x in it. And 1/2 of positive 3 is positive 3/2. So that indicates that the binomial is x plus 3/2 quantity squared. Okay, now apply the square root property. X plus 3/2 equals positive and negative square root of 49/4. The square root of 49/4 is the square root of 49 over the square root of 4. And so the numerator will be 7 because the square root of 49 is 7. And the denominator will be 2 because the square root of 4 is 2. So in the next step, I'll write x equals negative 3/2 plus and minus 7/2. And we can simplify further, so we do have to write the solutions individually this time. Okay, so one of the solutions is negative 3/2 minus 7/2, which is negative 10/2. or -5. The other solution is x equals -3/2 plus 7/2, which is +4/2, which is +2. So I'll try to make it a little more clear. The two solutions are x equals -5 and x equals +2. Well, that wasn't so bad. The next example, solve 2y to the second minus 10y minus 32 equals 0. Okay, so step 1, add 32 to both sides. So we get 2y to the second minus 10y equals 32. The coefficient of y squared is not 1, so we divide every term on both sides by 2. And we get y to the second minus 5y equals 16. Now we find a number to add to both sides of this equation so that the left-hand side is a perfect square trinomial. We find 1/2 of the coefficient of y. 1/2 of -5 is -5/2. Then we square that number. -5/2 squared is +25/4. So we are going to add 25/4 to both sides of this equation. On the left-hand side, we have y to the second minus 5y plus 25/4. And on the right-hand side, we have 16 plus 25/4. The left-hand side is a perfect square trinomial. So the binomial that it's equal to is y minus 5/2 quantity squared. Note that the minus 5/2 is the same number we got when we took half of -5. And then the right-hand side, you can think of 16 over 1 as 64 over 4, and then I'll go ahead and write it, 64 over 4 plus 25 over 4 is 89/4. So y minus 5/2 quantity squared equals 89/4. And now we can apply the square root property. And we have y minus 5/2 equals positive and negative square root of 89/4. And then note that the square root of 89/4 is the square root of 89 over the square root of 4. In the numerator, the square root of 89 cannot be simplified further, but in the denominator, the square root of 4 simplifies to 2. So I'll write the final answer here. We add 5/2 to both sides. So y equals 5/2 plus and minus the square root of 89 in the numerator and 2 in the denominator. So those are the two solutions. Yeah, I know this is probably agony to keep doing this, but we'll do the next two, time permitting. So this one, -4x squared minus 20x equals -4. The x squared term and the x term are already on one side, and the constant is on the opposite side. So what we do in this case, the first thing we do here is divide every term on both sides by -4. Okay, so negative 4x squared divided by negative 4 is 1x squared, minus 20x divided by negative 4 is plus 5x. And then on the right-hand side, negative 4 divided by negative 4 is 1. Okay, so now we take 1/2 of the coefficient of x, 1/2 of 5 is 5/2. Then we square that number, square the number 5/2. That just means 5/2 times 5/2, so it's 25/4. Okay, so we're going to add 25/4 to both sides of this equation, and we'll get x squared plus 5x plus 25/4 equals 1 plus 25/4. And then think of 1 as 4 over 4. 4 over 4 plus 25 over 4 is 29 over 4. And then on the left-hand side is a perfect square trinomial. So it's equal to the binomial x plus 5/2 quantity squared. That's equal to 29/4. And now we can apply the square root property. We get x plus 5/2 on the left-hand side equals positive and negative square root of 29/4 on the right-hand side. And similar to what we've been doing in this square root of the fraction 29/4, the square root of 29 will be in the numerator. The square root of 29 won't be able to be simplified any further. But in the denominator, the square root of 4 simplifies to 2. So our final results are x equals negative 5/2 plus and minus the square root of 29 divided by 2. One more example on this page. 2y to the second minus 14y minus 8 equals 0. We want the y squared term and the y term on one side by themselves and the constant on the opposite side. So step 1 this time is to add 8 to both sides. So we get 2y to the second minus 14y, leave some space, equals 8. When using this method, we want the coefficient of y squared to be 1. So if we divide every term on both sides by 2, we'll get 1y squared minus 7y equals 4. Now we can create a perfect square trinomial on the left-hand side if we add the same number to both sides. So we take 1/2 of negative 7, which is negative 7/2. Then we square the number negative 7/2, and we get positive 49/4. Okay, so we add 49/4 to both sides of this equation, and we'll get y to the second minus 7y plus 49/4 equals 4 plus 49/4. So we'll simplify the right-hand side. 4 plus 49/4. 4 is 4 over 1. The least common denominator is 4. So think of 4 as 16 over 4. So 16/4 plus 49/4. And that's 65/4. Okay, so this is now on the left. This is now a perfect square trinomial. So we write it as y minus 7/2 squared. The minus 7/2 is the same number that we got when we took 1/2 of minus 7. and then the right-hand side, 65 fourths. And now we apply the square root property. So since you've seen me do this a few times, having a denominator of 4, I'll just write y minus 7/2 equals positive and negative square root of 65 in the numerator and 2 in the denominator, since the square root of 4 is 2. And then one step, add 7/2 to both sides, so y equals 7/2 plus and minus the square root of 65 over 2. Okay, we're out of time. Tomorrow we'll move on to the next section in 9.3.